Okay. In that case, our first presentation of the day is Jan Sommer of the German Aerospace Center, presenting automation in the development process for the ReFEx GNC system. Jan, it's all yours.
Okay, thank you, Brendan, and welcome to my presentation about our development process and the automation of the development process for the ReFEx guidance, navigation, and control system. Next, please. As Brendan said, I'm from the German Aerospace Center, so we are the German, let's say, aerospace agency, but also mainly a research facility. We currently have 54 institutes at around 30 sites across Germany with 10,000 people. So we are already a quite distributed research facility where each institute has its own, let's say, area of expertise. And for larger projects, for instance, like ReFEx, we have to create collaborations between the institutes so that every institute can contribute their expertise for mechanical or software or other, let's say, service that they can provide. Next, please. So maybe a few words about ReFEx, the experiment itself. It's an acronym for the Usability Flight Experiment. And our goal is to have a technology demonstrator for re-entry vehicle. So the goal is to have a reusable first stage at some point. And here we try to go for the corner case where the first stage which returns is controlled solely through aerodynamic actuators. So the idea is that we will start from the Kuniba test range in South Australia, launch with a VSP-30 sounding rocket. Then after separation, we reach an altitude or an apogee of 120 to 130 kilometers. And then before re-entry with a small cold gas system, we get the first attitude for the re-entry into the atmosphere. Then at a later stage at lower altitudes and lower speeds, the spacecraft will go from a belly up attitude into a normal let's say, upright position through a roll maneuver, and then continue its flight along the predefined flight trajectory until the end of the experiment. Then it tries to lose as much velocity as possible and then touch down somewhere in the Australian desert. Next, please. So for us as a software developer of the system, the problem is, or the situation is that we have quite small development teams only, and they are distributed across DLR at different research sites and in different institutes. Then because it's an experiment, we have a lot of newly developed hardware and of course some experimental algorithms we want to use for the controlling. Then additionally, of course, we have a tight development schedule. So at some point we had to say let's say, traditional V model, ECSS style project management for our software is infeasible because we don't have the manpower for the full documentation efforts needed. And also because of the tight development schedule we will have for the different layers or, of the software overlapping development time. So for instance, the domain experts which do the control algorithms might depend on a feature from the base software which is not fully functional at the beginning when they start their development, or maybe also they will notice because it's a new algorithm that actually they need slightly different requirements. So we have to take this feedback loop into account. And the same it's for our AIT integration experts, that they will incrementally build up the flight system or also the engineering model. And somehow we have to cope with the fact that we develop against a moving target. Next, please. So then in the following slides with the continuous integration, continued delivery setup, of course, some of you might ask, is that really something new? I mean, this has been discussed by quite a long time, at least in the media or in the technical media. And probably it's not something completely new, but given from other space projects we have worked in and also our own experience, there are different levels of how strongly you integrate the concepts. So for example, if I asked you, Do you use a version control system? I guess everyone will say yes, of course. Then regular build jobs, I think it's also quite common to have automatic build jobs as part of the review process. Enforced is then already less common, I think, in some. It depends, of course, on your company or institution. And the same can be said, for instance, for unit tests. If you so first you write them, then you execute them regularly, but maybe only manually at certain review, let's say, project milestones. But then you can increase that to actually make it mandatory for every feature merge review process, or then even add the code coverage analyst to do the review process as well. And the same is for the automatic static analysis. I think there the tools actually have improved over the recent years so that it's now much easier to use them in a regular setup. So our goal is basically to have our main development branch develop our features in the feature branch, and then upon review, not just look at the differentials in the code, but actually look at all the collected data for the reviewer to support them to actually have a good guess how the software works and how the patch will influence the software. Next, please. So for us then to get to such a state, the most important things were a good communication and automation for our software development. And so we needed a central tool for communication regarding everything related to software, which is also accessible for all developers which are part of our project, but of course not necessarily all the colleagues which are outside of the project. And we wanted to integrate it with the CI/CD system to help with the day-to-day tasks and maybe create even some payoffs. So we were in the fortunate situation that 2 years ago, we had a DLR-wide rollout of the DLR GitLab instance maintained by the IT department. So there were no, let's say, maintenance overhead for us for the system. And this also meant that most members are now in general, or most colleagues are in general familiar with the website and how it operates. And it at the same time provides many features to build upon and has also a CI/CD service integrated. Next, please. So for us, our, let's say, requirements or what we wanted to achieve is to have, of course, managed access to the source code repositories themselves. And then have a central place for issue tracking, doing the code reviews, milestone planning, developer documentation, then of course the continuous integration setup, do our release management with all that. And then of course we established that we want to use our DLR GitLab instance. However, in the following slides, I will try to be more agnostic to the technology. So you can achieve more or less the same or essentially the same with GitHub, for instance, or also with your self-hosted Jenkins server. Next, please. So how do we organize our repository? We, of course, depend on some external and internal existing projects. External is most notably our real-time operating system. We use Artemis in this case, and it already provides a set of repositories with different parts of the Artemis ecosystem, and we do mirror those repositories internally so that we have them visible to everyone in the group, even if they are publicly available in the case of Artemis. And the same we do with our internal projects, which are usually in the scope of one institute, which is the main developing institute there. But so there to avoid the hassle with the access rights, we just mirror them as well in our own space so that everyone who's a member of the ReFEx consortium has access to that. And the same is for our own development, like the tasking framework. Outpost and tasking, they are both also available on GitHub as open source publications. And then we have our package registry and a small wiki where we can document developer information. Next, please. So we use existing software, as I said, and mirroring it into our internal space also gives us some nice advantages. So we can, because it's a mirror, we can track the upstream progress and see if there are any patches which are relevant to us. But we then also have our own internal issue tracking for things which are regarding this library, but only apply to our special case. And we can then also have, let's say, custom internal branches for our modifications. For instance, for our own custom board support package of items or some special proprietary drivers for additional for outpost libraries and these kind of things. Next, please. But our goal is also to contribute back to the upstream repositories or upstream projects. And this way, that's why we assign a developer who's responsible for the coordination for each of the external dependencies. And then we usually also encourage our colleagues to go the extra mile and polish the patches so that we can submit them upstream. Because then for us, the positive thing is we then also get, let's say, a free review of our submitted patches, which or suggestions how to do it differently from people who are more knowledgeable of the code base. And this gives us also a bit more confidence than in our custom additions. Next, please. So let's go to the continuous integration part. We started pretty small and said, okay, let's get familiar with how to set up the pipelines. And the easiest one is to just have a build job, because you have to build it anyway locally as well. And this way you already avoid the works on my machine errors if you forget to submit a header file or something like this. Also, you can then upload precompiled binary as artifacts, and this way execute maybe your program on a non-development machine. Next, please. And then we extended the setup to then, of course, run our unit tests. And as you can see in the lower part, then also the unit test shows up in the space where the code review happens. So you can see there as a review, okay, all the unit tests succeeded. There were no disabled unit tests, and there are no regressions. So that already is a good sign. And as a developer, you can also see the feedback immediately if you didn't run the unit test locally. So you cannot forget that anymore. Next, please. So the next step is then also to run the code coverage analysis of your unit test to see what lines are actually covered. And then you can generate, for instance, with LCAF, the HTML output and publish it as a static page as part as part of your project, and then have on the first page like a nice badge, and then you have directly access to it. But you can go even further. Next, please. And integrate that even in the review process itself. So you basically have then markings next to your differential view that tells you in the merge request or in the or the reviewer, it indicates which lines are covered by unit tests, which lines are missing, and then you can go into a discussion if that's okay, or if there should be maybe this is a unit test missing for this line. And of course, then you can add another job to the pipeline which compiles your documentation, for instance, your Doxygen documentation, and publishes so for everyone to see as a static page as well. Next, please. And then you can extend it even further. So you then can also have a job which enforces the correct code formatting so that the full code base looks more or less the same. Then you can add static analyzers. So on the right, you see a picture where I added standard off by one error, and it gets recognized by CPP check and directly shown in the review page of the merge request. So you can see, okay, I introduced the bug and I should fix it. Otherwise, the reviewer will probably tell me that I have to fix it anyway. And then you can also add, for instance, another job which then does a vulgar and mem checks and checks and derives the code metric for that and sees and checks if you have any problems in your allocations or deallocations. And finally, of course, then you can publish your releases and prepare packages for other dependent projects to consume your libraries. Next, please. So regarding the dependency management package delivery, that's kind of something which lacks C and C++ out of the box. And that's why we use Conan, which is supposed to fill the gap. And on the command line, it works similar to a Linux package manager. So it has recursive dependency resolution, and you can call it Conan install and then give it a package name, and it searches all the places it knows to find the package. The positive thing for us was that it's already integrated in GitLab, at least the basic version, to act as a Conan package registry. So we didn't need another service or a server. We could directly upload our binaries from the GitLab CI job to the registry, and then people could access them. And there, the same access management as for the repositories is used. So we already have, we don't have to do any further configuration there. The nice thing is also that for the people who don't like to build their own cross-compiler toolchain from source every time, we could deliver this then as binaries directly to them as a dependency, and then also always the right version of the cross-compiler tools for their system. Which makes it much handier for the people who work on a more higher level and don't want to care that much about compilers. And the nice thing about Conan is also that it's agnostic to the build system. So for instance, you see on the right, the let's say small dependency graph. You have the RTEMS parts, and the cost compiler uses a Python-based custom build system. The kernel uses auto tools. The network stack uses WAF, and we use sconce usually or CMake. And to put everything together manually can be quite a hassle. And Conan kind of gives you a standardized way to organize that. And also allows you to separate between release builds and maybe latest builds of the current mainline. Next, please. So how does it look like in practice? So you basically define in your repository a Conan file txt, which captures the dependencies, and then also tell it what kind of, for what build system it should generate configuration files. And because the dependency file is part of the repository, you also have track at which point in time of your development process you have which dependency. So if you have to go back at a certain point, you will get then also the library dependencies of that point automatically for you. And next, please. You then have to integrate that into your build system. So that's usually also quite some work to make this smooth, so that the build system first calls Conan to check the dependencies and fulfill them if they are not met yet. And then it generates for sconce, for instance, a configuration file, the sconce.conan, where all the include paths are configured in a certain way, and also the library path. And then you can feed your build system with that, and it can find the include path for the compiler and later the libraries for the linker. And other, let's say, all the major build systems for C and C++ are supported. And if you want, you can also produce your own generator, which is comparably easy because it's all Python-based, the setting. So it's good, it's well readable. And as I said, so for the more application developers, it's easier. For instance, they just hit one command and then it installs all the dependencies, including the cross compiler. Next, please. But to get there, we had to go through some painful times, and our lessons learned are, well, everything takes time. That's the main lessons, of course. Then also don't expect to get everything right at the first time, especially the pipeline scripts. First you start quite straightforward, and then you start also using templating there to make it more modular for build and debug setups and so on. But if you start easy, you have a compile test and maybe a code formatting check, and then you have quite low-hanging fruits which already improve your code base, at least the formatting, and also always tell you if your code can be compiled. Then what you probably have to expect is spending quite a significant amount of time in the beginning to set the pipeline script for all the different features, figure out how and in which format the results have to be published so that they can be consumed by your tools, so that GitLab, for instance, can show them directly as part of the merge request. And there's always also some time involved in the continuous maintenance of this. So sometimes you have to, there are new features or your priorities change and you have to tweak things again. But you have also quite some payoffs because all these kind of information are collected as part of the merge request itself and directly visible for the developer to see, okay, where can I improve already before starting the review and asking someone to take the time to look at the code. And for the review, it's also much easier because they don't have to do a lot of discussions, nitpicking about code formatting or small, simple mistakes, but they can focus on the technical details and the functional programming. So how is the functional part implemented? Are there maybe things to improve it there? So that then also gives you quite some time in the day-to-day work. Next, please. So to summarize, we need to develop the flight software of ReFEx in a quite tight time schedule and also with tight budgets. And for that, we had to search for a place or for a process to be more flexible and have some automated support in our development workflow. Also, basically since March 2020, so it's nearly 2 years now, we are basically 100% in home office. So it's not just that we have distributed teams, but now the teams themselves are also distributed at home. And so the setup of the central, such a central tool for the development exchange and the software exchange and also tracking of all the progress has been very valuable during this time. And then of course we use the CI for our code checks and package delivery. And our next step would be to go into the containerization of our runners so that we don't need physical machines anymore. And there was a nice panel discussion yesterday. So I think we have a few minutes left. I'm done with my presentation, and otherwise I will also answer some questions at Slack.
Yep, wonderful. Thank you so much, Jan. Looks like we do have some time for questions. So I'll start with the first one from Peter Fiddleman. Do you pull from upstream on a regular schedule or only when major patches appear?
We were essentially automatically. So our GitLab server triggers the upstream server every, I think, 15 minutes or something like this, checks if there are new commits and then just downloads them.
Okay. A couple other questions. Do you use Conan for handling all dependency management and relational repo management? Does this remove the need for submodules or subtrees?
It depends how closely everything is related. So it's very easy, for instance, for the operating system, where once you have done your board support package, it doesn't change that often anymore. And also it's quite a big dependency. And so there it's very easy to say, okay, I have my release cycle and I have my release there. For other, we have also some, let's say, submodules there where it's a bit more convenient, but we had situations before where we had then so many levels of submodules that it was very hard to progress a change from a deep module to a higher one. So there, I think Kona actually gives you a benefit because you can clearly communicate, I want this library in this version, but it gives you, it requires that you do have a management process for your releases and to do often releases so that you have the up-to-date features in there.
Yep. Okay. Next question from Jack White. Jan, it looked like you directly get coverage stats. Was it coverage in your merge request? Is that right? And did you use a plugin or is it part of GitLab?
Yeah, it's a feature of GitLab. So if you provide the code coverage as in a Cobertura XML format, then it takes some tweaking to find the right one and upload it to the right place. But you can then add it as an artifact and tell GitLab it's a Kobatura report, and it will then go through the files of your merge request, see and make these markings in the differential view.
Oh, okay. All right. We've got about a minute left for any other questions to filter in. Another question in the chat: what was the hardest part to set up?
I think so there were two main difficulties. So first is to get into the whole Conan thing. So you have to make recipes for all your libraries, but once you get the hang of it, it's actually quite okay. The second one was to write the GitLab pipelines, because at some point you want to you get to the spaghetti code level, where you have for each job a very long list of commands until you say, okay, now I have to make another indirection and create templates for that, and then you have to rearrange everything and get the syntax right. But once you have done that, then you have also a lot of stuff you can reuse in other projects. So if you use the same tools there, we now start copying lots of this stuff in other projects, and then you get quite a lot of good payoff of it.
Wonderful. Okay, I think that's all the time we have. Jan, thank you so much for your time today.
Thank you.